Beryl, Beryl, Beryl is my school. Best education reservoir for young learners just like me. Beryl,
Welcome to class and good day. We have been analyzing acid, base, and salts. Acid, base, and salt. And I told you when we started this topic that it's to take about 3 or 4 weeks. Okay, we have discussed acid, we have discussed base. Today we shall discuss salt and all it contains. But I hope you are enjoying yourself reading, and but I'm yet to get a feedback from you from what we've done so far. So please do send your notes and do my assignment. Thank you. Today we'll look at definition of salt. Definition and types of salt. We'll also look at preparation and uses of salt. If there is time, we'll go into explaining efflorescence, deliquescence, and hygroscopic substance. Yes, these are the specific objectives that shall drive this lesson. The first thing is definition and types of salts. Next, we'll look at preparation and uses of salts, and then we'll explain efflorescence, deliquescent, and hygroscopic substance. Is that clear? Okay. Today, definition. What is salt? What is salt? If you are to define a salt, we say a salt is a compound that contains positive metallic ions or ammonium ions. A salt is a compound that contains positive metallic ions, hydrogen ions, or ammonium ions. Is that clear? Okay, we can write that down. That's a salt is a compound that contains positive metallic ions and ammonium ions with acid radical ions. Your definition has to be concise. The first thing is a compound. A salt is a compound. It contains positive metallic ions. It contains ammonium ions with acid radical ions. Did you get that? A salt is a compound that contains positive metallic ions and ammonium ions with acid radical ions. So if I have NaCl, as far as it contains a metallic ion and it contains a radical, is a salt. If I have as well, let's say Zn into OH, okay, this is not a salt because of the hydroxide ion. Rather, this is a base. This is a base. It is zinc hydroxide. This is zinc hydroxide. But if you have H, or let's use NH4 into brackets 2SO4. You see it? This is ammonium ion. This is an acid radical. This is ammonium ion. This is what? An acid radical. And we have said that it at least must contain, if not the metallic ion, it contains what? Ammonium ion coupled with acid radicals. Coupled with acid radicals. Is that clear? Okay, as we explained earlier on, before I had to give you a concise definition of it on the board, we said that a salt is a compound that contains positive metallic ions or ammonium ions and negative acid radicals. Okay, a salt can be said to be formed when the hydrogen ion of an acid is replaced by metallic ion or ammonium ion. I go by it again. A salt can be said to be formed when the hydrogen ion of an acid is replaced by metallic ion or ammonium ion. Okay? Apart from that, there are 5 different types of salts. There are 5 different types of salt. But before I go into that, let's show how a salt can be differentiated from maybe an acid or a base. We said an acid is, for instance, HCl is an acid. Okay? A base is Zn into OH. That's a base. Don't mind the fact that it contains metallic, it contains a metal, and then hydroxide ion is still a base. But if I have ZnOHCl, this is no longer a base, but this is a salt because it contains metallic ion, it contains hydroxide ion, or you call it acid radical ion. I can group this as an acid radical ion, negative radicals. Is that clear? So you can differentiate between an acid and a base and a salt. We said an acid is a substance that will produce hydrogen ion or ozonium ion when dissolved in water as the only positive ion. And then we said that a base is a substance containing oxide and hydroxides of metals. Oxides and hydroxides of metal. But a salt contains positive metallic ion, it contains ammonium ions, positive metallic ion or ammonium ions, and then negative acid radical. Is that clear? Okay, types of salt. Now, the first type of salt is the one you know very well, you use at home. We said there are 5 different types. There are 5 different types of salt. The first one, which is normal salt. Normal salt. This is the salt you use in the kitchen. Okay? The second type is the one that contains hydrogen ion, which is acid salt. Acid salt. This type of salt is not advisable for use for consumption. I have normal salts, I have acid salts. The third kind of salt is basic salt. Basic salt contains hydroxide ions, and then we have a fourth, which is double salt. Double salts. And then the fifth type of salt is complex salts. Complex salt. These are the 5 different types of salts that we currently have. Okay, I didn't tell you that salt can also be classified. Salt indeed can be classified into soluble and insoluble salts. I think we'll get to that if I must discuss that in details. But just have it at the back of your mind that there are 2 classes of salt, the soluble and the insoluble salts. Just like we have 2 classes of bases, where we have the soluble base and the insoluble base. I told you that soluble base are called alkalis. Soluble bases are called alkalis. You know that already. Okay, let's come back to salts. So we have normal salts, we have acidic or acid salts, we have basic salts, we have double salts, and then we have complex salts. Okay, now I have decided to explain some of the salts. First of all, the normal salt. We said a normal salt is formed when all the hydrogen ions of the acid have been completely replaced by metallic ions or ammonium ions. A normal salt is formed, yes, when all the hydrogen ions of the acid have been completely replaced by a metallic ions or ammonium ions. Examples of normal salt. Now see how it's replaced. Now if you have hydrogen chloride gas, that is an acid, hydrochloric acid, reacts with a base, sodium hydroxide. It will form sodium chloride and water. It forms sodium chloride and water. Now, this salt is a normal salt because the hydrogen ions of the acid has been completely replaced. You see it? By metallic ions. The hydrogen ion of the acid has been completely in the sense that this hydrogen, if it was present here, I will call this a normal salt. Take for instance, I have sodium hydrogen chloride. This is no longer a normal salt because of the presence of hydrogen. But as it is now, the hydrogen has been completely replaced. So it forms a normal salt, and this is a typical example of neutralization reaction. Now let's go to the next example. Sulfuric acid reacts with sodium hydroxide to form a sodium tetraoxosulfate. Sodium tetraoxosulfate with water. Sulfuric acid reacts with sodium hydroxide. This is an acid and this is a base. This is a typical example of neutralization reaction. You form a compound of sulfur, a salt of sulfur and water. The same thing is also applicable here. It reacts to form sodium tetraoxophosphate. This is phosphate. This is sulfate. You see it? This is phosphate because it's phosphorus. This is sulfate because it's sulfur. So you take notes. There is a salt of sulfur, which is sulfate. There is a salt of phosphate or phosphorus, which is phosphate. Is that clear? Okay. These are typical examples of normal salt because you have not seen any hydrogen ion in it. You have not seen any hydrogen ion in it. So it shows that it's a normal salt. That is, all the hydrogen ion of the acid have been completely replaced. If it was not completely replaced, it will not form a normal salt. Now let's move over to acid salt, which is the next one, acid salt. On the board, this other side, I said an acid salt is formed where the replaceable hydrogen ions have only been partially replaced by metallic ions or ammonium ions. That is, an acid salt is formed when the replaceable hydrogen ions have only been partially replaced by metallic ions or ammonium ions. Acid containing more than 1 mole of hydrogen ions per molecule can form acid salts, as the hydrogen ions can be replaced in steps. Do you know what that means? Acid containing more than 1 mole of hydrogen ions per molecules. If it contains, let's say, 2 hydrogen, 3 or 4, just like you have H2SO4. H2SO4. Now let's show a typical example of acidic salt using H2SO4. If you have H2SO4, because it contains more than 1 hydrogen ion, if it reacts with sodium hydroxide, as a 2NaOH. Now the salt that will be formed will be acidic salt in the sense that you have the salts H2SO4, you have NaH, you see it? NaHSO4, you see it? Plus H2O. You see, the hydrogen ion has not been completely replaced. Now we need to balance this equation. I know you can balance the equation very well. Attempt balancing it and write it out for me. But the fact is that the salt, the acid, is the hydrogen ion of this acid has not been completely replaced in this salt. That's why we still have sodium hydrogen tetraoxosulfate. You see it? Instead of what we had here, sodium tetraoxosulfate. Instead of sodium tetraoxosulfate, which is a normal salt, because all the hydrogen ion has been completely replaced. But whereas for an acid salt, the hydrogen ions are not usually completely replaced. So we still have a mole or an atom of hydrogen present in it. Once this happens, it is no longer a normal salt, rather an acid salt. Is that clear? Okay. Now, look up. If you look at this salt, we are trying to explain sorts of acids. Now you've seen that there are 3 atoms of hydrogen present here. If it reacts with a base, potassium hydroxide, now only one of its hydrogen ion has been replaced. It's saying only one of the hydrogen has been replaced in the sense that this salt formed is an acid salt. For the fact that you have potassium hydrogen tetraoxophosphate. That's the name of the salt. Potassium hydrogen tetraoxophosphate. Isn't it? That salt is an acid salt for the fact that the hydrogen ion from the acid was not completely replaced. It was 3 atoms and now it is 2 atoms. Only one has been replaced or taken out. Also, if we look at basic salt, we said a basic salt is formed when the hydroxide ions. Now we are not saying hydrogen ion. When we are defining an acid, we specify hydrogen ion or oxides, hydrozonium ion, I beg your pardon. And now when we are defining a base, we said bases are oxides of metals or hydroxides of metals. Bases are oxides of metals or hydroxides of metals. That's why if we are to define a basic salt, we said is a salt formed when the hydroxide ions of a base have not been completely replaced by negative acid radicals of the acids. Now if you have, this is sodium hydroxide, zinc hydroxide, it reacts with an acid. A base reacts with an acid, is forming zinc hydroxide. You see the zinc metal is present, the hydrogen ion is there, and the chloride ion is also present. Now these will not be described as a normal salt. This can be described as an acidic salt, but this can be described as a basic salt. Why? In the sense that it contains the hydroxide ion. Is that clear? In the sense that it contains the hydroxide ion, because the hydroxide ion was not replaced or completely replaced. Whereas we have 2 moles of the ions present here. Here is just a mole. It's just a mole. So zinc hydroxide now from zinc hydrogen, you see it? Hydroxy chloride. Zinc hydroxy chloride. From zinc hydroxide, from zinc hydroxy chloride. This is basic salt with water that is formed. Is that clear? So you take note what happened in each of the salts that are formed. For the normal salt, all the hydrogen ions were replaced. For the acidic salt, not all of the hydrogen ions are replaced. Then for the basic salt, not all the hydroxide ions are replaced. Those are the things that qualify them to be called either acidic salt or basic salt. Is that clear? We'll move on to the 4th type of salt, which is double salt. Double salt. We say a double salt can be said to be a mixture of 2 different salts containing 2 different metallic ions, but common negative acid radicals. I take that again. A double salt contains 2 different metallic ions, but common negative acid radical. Example of a double salt is ammonium iron 2 tetrazol sulfate 6. Ammonium, this is NH4 in bracket 2SO4 dot FeSO4 dot 6H2O. That's a crystalline salt. It contains water of crystallization. As is a crystalline salt. Okay, ammonium iron 2 tetrazol sulfate 6 is a typical example of a double salt. And a double salt has its own property. It contains two different metallic ions and then a common negative acid radicals. It contains two different metallic ions and a common negative acid radical. And the common negative acid radical ion is what we've seen here, SO4, SO4. You seen it? This is ammonium ion, this is iron. You seen it? And the common radical, negative radical is SO4, which is this. So that's why it's ammonium iron 2 tetrazol sulfate 6. Let's look at another example of the same double salt. Potassium aluminium tetrazol sulfate. Potassium aluminium tetrazol sulfate. This is the formula. Potassium aluminium tetrazol sulfate. It is also a crystalline salt because you have seen water of crystallization in the salt. Now, look at this caption that double salts are generally called alums. I don't know if you have seen an alum before. What is it used for? In water treatment. An alum can be used to coagulate the impurities that are present in water. Sometimes you put a molecule or a drop of an alum in water, and before some minutes or hours, all the particles or depth that are present in water will go down the bottom of it and then will coagulate. Is that clear? That's a function of. Then the last, which is complex salt. Complex salt contains complex ions. Complex salt contains complex ion. A complex ion contains a central positive metallic ion bounded to atoms or group of atoms or ions called ligands by coordinate bonds. A complex salt contains a central positive metallic ion bounded to an atom or atoms or group of atoms or ions called ligands by coordinate bond. Let's look at examples of complex salts. Okay, other examples of complex salts have been highlighted on the board. Now, if you look at the first example we discussed earlier on, we said potassium hexacyanoferrate 3. Potassium hexacyanoferrate 3. Can you pronounce it with me? Potassium hexacyanoferrate 3. That's the formula. K3Fe into Cn bracket close 6. Now, if we are to look at the complex ion of this salt, is what I've just analyzed. The complex ion of this salt is, you see there is 3 mole of potassium ion there, plus the complex salt itself. The complex salt is Fe into Cn6. That's what we call the ligand. This is the ligand. Don't forget I told you about the ligand, Cn. That's the cyano, that's Cn. But cyanoferrate is the complex salt. The complex salt is cyanoferrate. Just like you have tetramine copper 2 tetrazol sulfate 6. Tetramine copper 2 tetrazol sulfate 6. Now, this is the formula for this salt. Tetramine copper 2 tetrazol sulfate 6. Okay? And then if we are to see its ionizability, this is the complex salt as it is. This is the complex. Because of my time, let's go into method of preparing salt. How do we prepare salt? Now, before I show you how you can prepare salt, I want you to understand that we made mention of the classes of salt earlier. That salts are classified as soluble and insoluble. Now, their method of preparation varies. For soluble salt, we have precise method of preparation, which are also different from the method of preparing those salts that are insoluble in water. Now for the salt that are soluble in water, I will say preparing soluble salt. Soluble salts are prepared by method of crystallization. Soluble salts are prepared using the method of crystallization, and I have highlighted those methods. The first method is reaction between metals and acids. Reaction between metals and acids. Any of the metals you know. Now I've picked zinc. If zinc reacts with hydrogen tetrasulfate 6, it will produce zinc tetrasulfate 6 with the evolution of hydrogen. So when we discuss reaction with metals, for every reaction with metals, there is the evolution of hydrogen gas. There is evolution of hydrogen for the preparation of salt. So zinc metals, if react with an acid, it will produce the salt zinc tetrasulfate 6 with the evolution of hydrogen gas. Okay, that's the first method, reaction between metals and acid. Another method that can be employed in preparing soluble salt is reaction between alkalis and acid. That is neutralization reaction. Reaction between alkalis and acid. Sodium hydroxide neutralizes sodium chloride to form normal salt and water. That salt is prepared. It's as simple as that. Then the third method of preparing a soluble salt as well is reaction between metallic triazo carbonate 4 salts and acid. Reaction between metallic triazo carbonate 4 salts and acids. Now we have lead triazo carbonate 4 on the board. If it reacts with triazo nitrate 5, it will produce lead triazo nitrate with water and then carbon 4 oxide. So this salt is a soluble salt. It's a soluble salt. Now if I quickly do a recap, I said preparing soluble salt, there are 3 methods that are involved. First is reaction between the metals and acids. Reaction between the metals and the acid. The second is reaction between alkalis and acids. And then the third is reaction between metallic triazo carbonate 4 salt and acid. In whichever case, all the reactions are between either the metals and acid, or neutralization reaction, which is the sodium base and then an acid, or triazo carbonate 4 salt with an acid. All of these 3 methods can help you prepare soluble salt. Now, quickly, preparing insoluble salt, we have, this is done by precipitation reaction, or you can call it by reacting it directly, right? Reacting those elements that are involved directly. Now, I have highlighted precipitation reaction on the board. Lead triazo nitrate 5 reacts with sodium hydrogen chloride, beg your pardon. Lead triazo nitrate 5 reacts with hydrogen chloride. We produce lead chloride and salt. Is that clear? Okay, so I think this is where we'll call it a day for this class. In our next class, we will look at uses of acid. We'll also discuss efflorescent, hygroscopic, and deliquescent substances. Do have a nice time. Please copy the note and then enjoy yourself. Bye.